Hi, today's notes are on 3.1b. So this is our second method of how to solve quadratic equations, and today we're going to solve by square roots. Before we do that, let's review solving by graphing. Okay, so please remember that when you solve by graphing, you need to either find the x-intercepts, if you just have a function equal to y or 0, or if you have a function equal to a number, you're going to draw a horizontal line at y equals to that number and find the points of intersection. Okay, well, this is a special case where you have to have it equal to a number. Usually we're going to have just solve by graphing. Okay. So remember, when you're solving by graphing, you're just finding the x-intercepts. So let's graph it. Well, we know that this x-intercept is positive 7, and this one is negative 2, because this is intercept form. And technically, if those are our x-intercepts, aren't we done? Right? So we have one here at positive 7 and negative 2, but we don't have to do more work, so we're done. There's no need to graph at this point, right? Because you've already solved it, and it just says solve. So letter B is a little bit trickier, right? So this one we don't have the x-intercepts. This is vertex form. Maybe take a moment, pause the video if you're able to, and see if you can do this yourself. Just a heads up, there's not going to be nice x-intercepts. So if you're still with me here, the vertex is 3, negative 4, which works if you use the 1, 3, 5 pattern, but please remember that your pattern here needs to multiply by 2. Okay, so it's 1, 3, 5, 7, but we're really going to times 2. Which means our new pattern is 2, 6, 10, 14. So if we count up 2 over 1, that's great, but then up 6 means that we miss this point. Okay. That does not mean that we don't have a solution. We absolutely do have a solution. It is just somewhere between 1 and 2 and 4 and 5. So this is a decimal value. Okay. So they still exist, it's just decimal x-intercept, which means that we now need to find a better way or a different way than solving by graphing, because it's not effective right now. So if your solutions, which are also known as x-intercepts, roots, or zeros, are not integers. Integers are whole numbers. Okay, so if your solution is not a whole number, then solving algebraically is more effective than solving by graphing. So solving by graphing sometimes does not work. Okay. And before we review, or before we start, let's do a quick review. Inverse operations, addition and, hopefully you remember it's subtraction, multiplication and division, and this is a new one, squared and square roots. So that squared is just looking like that, and square root looks like this. Okay. Now I do know that a lot of teachers up until now just draw it like that, right? The square root symbol. The reason why I have this extra line on top is because in chapter 5 of our textbook, we are going to be writing a number here. And so if you write a number, you leave a space for this, because what if we put like x squared? Do you see how like it becomes, if you get messy, or x to the 5th, let's put, right? Do you see how that starts to question, like, is it with your x or is it the one that goes here? But do you see how now this is very clear, this is x times the 5th root, okay? I also close it here at the end because in chapter 5 again, we're going to be adding and subtracting things after, right? So it's nice to know that this closes off and there's no extension of like these numbers are outside versus some numbers are inside. You don't have to write it my way yet. I think you'll see my way eventually. So a quick review. If x squared equals 9, that means x times x equals to 9. What number has to be true for x? Or what number makes this equation true? Hopefully you have positive 3. But then my question for you is, what about negative 3? Does that also work? Right? Negative 3 and negative 3 multiplies to 9. So if you take the square root of both sides when we're solving an equation, you're always going to have a positive and a negative. And I know some of you guys are going to forget this. It's too easy to forget. So every time we do this, where we square root and square root, I'll show you that I'll write in plus or minus. So today we're not actually learning anything new. This is just a new inverse operations. We're going to solve equations just like we did in Algebra 1 and get things by itself, but we have something new to get rid of. Taking the square root is the same as inverse operations, and this method only works when you have vertex form or standard form when b equals 0. Now what does that mean? It means that if you have like ax squared plus bx plus c, b is gone. And do you see how there's only one x here? In vertex form, only has one x as well. Okay, so solving by taking the square root only works when you see one x. The goal is to get x squared by itself and then square root both sides. So let me show you what I mean. Now, if you're any kind of shaky on solving equations, I really suggest that you circle what x is stuck with. Because once you do that and you leave a number out, it's pretty clear what you should do to get rid of that number, right? So to get rid of the negative 3, we add 3. We have 2x squared equals to 50. And now if you circle x squared, right? I didn't circle 2 in the x because there's only one 2 and there's 2 x's. So those are stuck together. Well, then I can divide by 2. And I get x squared equals 25. Remember, our goal is to get x squared by itself. Then we can square root both sides. So this is our new step here. Okay. When you do this, there's going to be a plus or minus. I write it like this so that you can see that first I got this and then I got this. I know some teachers do this. And they write it in right here and you cross it out. But the problem is it doesn't show that you got this first. Like this step is important to know that this is what I get from here and then I square root, which cancels out the squared. And we get x equals plus or minus. Square root of 25 is 5. I know that, but what if I gave you like a huge number that you don't know? So what you would do, on your graphing calculator, there's a square root symbol right above the x squared because they're inverses. And how you get there is you use a second and blue. Okay, on my other calculator, which some of you guys also have, my second button is yellow. So then you would go second because that square root is yellow and it's the same button. Okay. At that point, it's 25. It only tells you positive 5 because there's no x. So this positive and negative only shows up when there's an x, and your calculator doesn't see that, so you need to remember to write that in. Okay. Let's do another example. Same idea. Circle what x is stuck with and what's left out. That means I'm going to subtract 10 on both sides. You'll have negative parentheses, x minus 1 squared equals negative 25. Do not distribute this and make this into standard form. Okay, so there's two rules when there's parentheses. If you have an exponent, that negative never goes in. If you put the negative distributed in, that means that now there's 2 of them, but we only have 1. So the other rule that you cannot do is you cannot distribute the exponent in. Exponents are special, so they don't get distributed backwards the way that normal numbers do. Okay? So what do we do instead? Well, we want to get x squared by itself, right? So that's this part. There's that extra negative in front that I can divide by to get rid of. That gives me x minus 1 parentheses squared equals 25. Well, if I circle what's stuck together, clearly the x and the 1 are in the parentheses together. And I'm going to take the square root of both sides. That gives me x minus 1 equals, and I should probably write this in because I almost forgot, plus or minus 5. Now, if I didn't have this right side, what I would do is add 1 to both sides. Do you guys agree? And so now we have x equals 1 plus or minus 5. And it's a positive 1, in case you were wondering, right? So make sure you know which sign it is. Now, the reason I wrote it this way is because now I know that we have two things we need to do. We're going to say that we have 1 plus 5 equals 6. And please do not tell me it's negative 6 for the other one. You have to write it out. 1 minus 5 equals to negative 4. And these are your two solutions. Okay? So think of it this way. How you can check is if I have an axis of symmetry at 1, am I going to be at 6 and negative 6 for my x-intercepts? No, right? So if I start at 1, I'm going to add 5 from 1, and I'm subtracting 5 from 1. So I'm going to be at 6 and negative 4. Okay. So let's do a quick review. When do you know to solve using inverse operations? You do that when I see only one x. Okay, so tomorrow we're going to talk about what to do when we see ax squared plus bx plus c equals 0. But right now, we don't know how to do this. Okay. So here's your U-try. I want you guys to take a moment and pause the video. Okay, but I will give you a hint that number 3 is a little weird, and number 6 is a little weird. Okay, so I want you to pause it, and then I'll go over number 3 and 6. And I want you guys to actually practice these, please. Okay. I hope you pause your video. You're going to get x equals plus or minus 4 here. This one will be x equals plus or minus 5. This one I want to go over. Okay, so we know that this is stuck together. We're going to add 9. We get 4x squared equals 9. Remember, we want x is by itself, so we're going to divide by 4. Okay, we're going to divide by 4 on both sides. And then we get a fraction, and most students freak out. Well, don't freak out. If you have a fraction, it means leave it as a fraction. I don't want decimals, because usually fraction problems you can do without a calculator. So watch what happens. I know that we're going to take the square root of both sides, right? Which is what we would do if nothing had happened, or like if it wasn't a fraction. There's going to be a plus or minus. I'll write it over here. So we have x equals plus or minus square root of 9 over 4. Well, that's the same as saying plus or minus square root 9 over square root 4, which is just plus or minus 3 over 2. Not too bad. Okay, so much better than plugging it into your calculator and not knowing where that number came from. Okay, so let's do quick checks here. Pause again, do 4 and 5. 6 is going to be a little weird. This will be negative 2 and 8, I believe, and this will be, sorry, give me a second. I think it's 6 and negative 2, but if you think I'm wrong, let me know, please. Okay. Wait. Yeah, I think so. No. Hang on, so it'll be negative 2. Negative 2 plus 4. That's positive 2 and negative 2 minus 4. Sorry, had my signs switched. Negative 6 and positive 2. Okay, so this last one, quick review. This is from B on the front. So first off, this is our graph. Okay, we know it's not going to be whole number answers because that was the issue we had. So right now, please remember that if we have y equals, we're going to set it equal to 0. And then we're going to solve. Okay, all the steps stay the same. We're going to always divide first, right? Because these are stuck together. Now it looks like we've run into an issue. Well, hopefully you've learned from our fraction one. Don't mess with it. Okay, so we know that here the next step will be to square root. And yes, I know it's not a nice perfect square, but I still know that I can square root. So what do? Well, if you don't know what it is, leave it as a plus or minus square root 2 equals x minus 3. And if things weren't crazy looking on the left side, I would add 3 no matter what to get x by itself, right? Now, please keep in mind, let's figure out what the square root of 2 is. That's a decimal. So notice you can't take 3 plus 2. Okay, we're going to take this decimal and add a whole number. So I want you to think of it as what you have is you have a whole number 3, and you're going to add or subtract a decimal. And we cannot combine them right now because they're not like terms. But this is your final answer on a test. But what does it mean? Okay, so let's imagine if we punched it into our calculator and had a positive and a negative, I would do this. Okay, 3 plus square root 2 and 3 minus square root 2. And so those are our estimated values, approximately 4.4 and approximately 1.6. And if we take a look at our graph on the previous page, it is at 1 point something and 4 point something. Not exact, but it does match our graph. Okay. The last thing I want to cover is these problems at the bottom are going to be exactly the same, except they're not going to have perfect square answers. So hopefully from geometry you remember that we need to simplify our radicals if possible. And you are going to find the largest perfect square to divide your number by. In this case, I know it's 50, right? So we know square root of 25 and square root of 2. So we know this is 5, and that's why it's 5 root 2. Well, what if you're not so good at your times tables? First off, we need to know what the perfect squares are. Ready? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and let's do 7 squared. 1 squared is 1 times 1 is 1, 2 times 2 is 2, 3 times 3, not 3 times 2. Okay, that's 9. Oh, sorry, 2 times 2 is 4. Sorry about that. 4 times 4 is 16, 5 squared is 25, 36, and 49. So those are the numbers we're looking for. Now, this gets a little dangerous because a lot of students know that 48 is 4 times 12. They do this. And then they'd say like, okay, well, I know square root of 4 is 2, so it's 2 root 12, and I'm done. But can 12 be further divided by a square root, perfect square? Yes, 12 can be divided by 4 again. Well, that means this comes out again. So your final answer is 4 root 3. Now, what if we take a look at our factor sheet and we recognize that 48 has a bigger perfect square, 16. So we chose 16 times 3 instead. Well, that's much faster because that brings us to 4 root 3 immediately. Okay? So right now you're going to solve this. I'll do the first one with you just to confirm, and then the next 8 and 9, try yourself. Okay, so the steps are exactly the same. No freaking out here. Make sure you copy the squared down. For some reason, students forget that a lot. You divide by 5. We have x plus 4 squared equals to 20. Square root both sides. And we now get x plus 4 equals plus or minus square root 20. Well, square root 20 is square root of 4 times 5. So I'm going to do two things at once. I'm going to subtract 4 on both sides, which gives me x equals negative 4 plus or minus, instead of square root 20, I'm going to write 2 root 5. And we're done. Okay, so you should get those kinds of answers for 8 and 9 as well.